All right, now we're moving on to the second part of characteristics. First one we're talking about is called end behavior. And the end behavior is just telling us what's happening at the ends of the graph. Now the ends meaning if you go along the x-axis, either to the far right side or to the far left side, I want to know what are the y values doing. So if I'm over here at this x right here, I want to know what the y values are doing. So here's the y value down here, right? So then if I keep going this direction, let's say we get to here, I want to know what the y's are doing. So here was the y, the next y is down here, and so on and so forth until it goes forever down to negative infinity. So as I was going left, this way is left, the graph was going down. And for left on the x-axis is negative infinity. So on the left side, my graph, or as I moved to the left side of the x-axis, the graph was headed down in the down direction. Now if you look at the other side, as I'm going to the right on the x-axis, which will be positive infinity, what's my graph doing? Well, here's one value. Okay, I go a little bit more to the right. Here's another value. Keep going. If you look at these values on the graph, it's going up. So it's going to end up at positive infinity. So this idea of end behavior is just the bigger scope. It's looking at it and saying, okay, wait a minute. I don't have a whole graph, but based on its behavior, if I were to look all the way to the right side and go to negative infinity, or sorry, to positive infinity, which direction would my graph be growing in? Would it be going up to positive infinity, or would my graph be going down? So the statements, the descriptions look like this. So you're going to have part of the statement that's talking about the x's, right? What is happening on the left side going to negative infinity? Sorry, that's this one. And then you'll have another one that's talking about what's happening on the right side. So this right here is the right side. And this one is the left side. Now, how do you know the difference? Well, if you're on the x-axis and you go to positive infinity, then you have to go to the right direction. If you're on the x-axis and you're going towards negative infinity, then you're going left on that x-axis. So you'll always have two statements, and they will always look like this. Always, always, always. You'll have one of these and one of these. And then you'll also have this statement here, f of x with the arrow. That arrow just stands for quote unquote goes to. I'll read one in words in just a minute for you. So again, you're going to have these two statements. Oops. Oopsie. Poopsie. Sorry, that was a commercial. I don't know why that came out. It was a commercial that used to get stuck in my head, and I can't remember all the words that it just popped out. Sorry. So these are the two different types of possible answers that you can have. And here's how they are read. This first one right here says, as x goes to, that little arrow means goes to, whoops, that was ugly. So that little arrow inside there, this guy right here, means go to, goes to. So the arrow means goes to. All right, so again, let me start at the beginning. This first statement says, as x goes to positive infinity, which translated says, as x is going to the right, as we're going on the right side of the x-axis, and the comma set is a pause, f of x goes to, f of x is the same thing as y. I'm not doing very good with these special colors. So this first one right here, reading the whole first thing, as x goes to positive infinity, f of x goes to positive infinity. when you're talking about the f of x and the direction it goes, the y direction the y goes, this would be the same thing as saying up. So this whole statement right here, this first one says, if you go on the right side of the x-axis and look for the graph, the y's are going up. So as x goes to the right, y goes up. That's the basic translation for non-mathematical speak, right? This is all in math language over here. So this next one right here says, as x goes to negative infinity, or left, f of x goes up. Okay, this one says, as x goes to positive infinity, that's to the right. F of x goes to negative infinity, which is down. Okay, this one down here says, as x goes to negative infinity, which is to the left. F of x goes to negative infinity, which is to the down. It is to the down. What? So you have got different options for this. You will only have two statements. One of them will be talking about the right side, one will be talking about the left side. Now you will either have a right side that says this one or that one, and then you'll have a left side that either says that one or that one. Anyways, getting stuck up in the details. So let's look at this one. We decided that on the left, it was going down, and on the right, it was going up. So here's the statement. Simple words, and you can use the same statements every single time. So to say on the left, you would say as x goes to, left is negative infinity, so negative infinity, comma, f of x goes to down, which is negative infinity. Okay, there's one statement. I just made a statement about the left side. Now the right side. As x goes to positive infinity, comma, f of x goes up, which is positive infinity. And that's the description of that one. And that's all this basically is you're looking at each side of the graph. On the left, what's it doing? On the right, what's it doing? So down here, this one, as I'm moving left over here, which is negative infinity, I'm looking at the graph and I'm going to it right from the x-axis, and all those values are increasing, so it's going up to positive infinity. Okay, so the left side goes up. That would be written as x goes to negative infinity, that's how you say the left side, f of x goes up to positive infinity. Okay, this bottom one, or sorry, the other side, as we go to the right, if you keep checking, now granted these numbers are down below the x-axis, but we're not looking at what the actual values are. We're looking at, as I go to further x's to the right, where are my y values going? Well, from here to here, that's increasing. From here to here, it's increasing. And you can see this arrow right here. Which way is it pointing? It's pointing up. So we would say on the right side, I don't know what all this draggage is and where those black marks keep coming from, but whatever. So on the right side, it's also going up, which is perfectly fine. We would say as x goes to the right, which is positive infinity, f of x goes to up, which is also positive infinity. And those would be your two statements about end behavior. Here's kind of a diagram about it. This is when you go to the right. And this is talking about when you go up. This one right here, this is left, and this is down. So your statements will have it as x goes to negative infinity, that's the left side. As x goes to positive infinity, that's the right side. And then this is the part that's going to change based on the problem. Look, everything in this highlighted part, they're all the exact same. The only thing that changes is this positive or negative. You just have to figure out, are both ends going up? Is one going up and one going down? And then fill in the correct pieces. So, end behavior of this guy. Now, this one's weird because it doesn't go on forever, right? But let's look at it. As we go over here to the right, we can't really keep going to the forever, right? Basically, it stops right here at this value. So all you can do is say as x goes, now I can't say infinity because it stops there. So I would say as x goes to 10, f of x goes to this value. It stops right here. So it goes to 3. Then for the other side, going to the left, right, the farthest it goes is this number right here. So now as x goes to -5, f of x goes to, here's the lowest value, which was -3. So in this case, there's no infinities because we can't go beyond the graph if it stops at a certain spot. So as far as the test goes, I wouldn't give you one of these where it stops on both ends, but just so you understand, that's what happens. If you can't go to infinity, you just describe it to the value you can go to. Okay, let's look at this one. We're going to have two statements. One is going to say as x goes to the left, -infinity, comma, f of x goes to, and then we would have a statement as x goes to the right, which is +infinity, f of x goes to, and then we'll give it an up or a down. So looking at this picture, I'm going along the x-axis, I'm looking at the y's, and it looks like they're going up and up and up, which is +infinity. So we would say that as x goes to -infinity, f of x goes to infinity. Right? Now, to the right side. So as I'm going over here to the big guy forever, how did I get that color? I don't understand that black thing. Sorry, side note, but I must be doing something. So if I were to try and go over here to forever to +infinity, I couldn't. My graph ends right there. So as a statement, as a problem, I would be okay with giving you credit for that answer right there. If you want to go a little bit further and kind of try and describe it, you would say as x goes to 1, comma, f of x goes to, stops right there, so it goes to 1. See, the problem with this description is it doesn't tell me which direction it goes to 1 from. So it doesn't tell me, like if I was just given this and not the graph, it doesn't tell me which way it came from to go up to the 1. Okay, so this one right here, two statements. As x goes to the left, f of x goes to, and then as x goes to the right, f of x goes to, okay, left side, here's the graph. It looks like it's going down forever as I go this way. So we'll say -infinity there. Okay, this right side, this is as far as I can go, and it looks like that's as high as it goes. So instead of infinity right here, I would say 4, and f of x goes to 4 also. Again, that statement isn't completely correct because there's more to it than that. But for now, that's all I need you to worry about is that you understand that it goes there. Okay, this one really quick. On the left, which way is it going? Going down. As x goes to -infinity, f of x goes down, which is -infinity. Okay, to the right, look what's happening here. On the right side, as x goes to infinity, f of x is going up, which means it's going to +infinity. Even though there's stuff missing in between, it doesn't matter. We're only looking at the ends of the graph. As far right as we can go and as far left as we can go.